Welcome back to some sum and difference properties notes. I apologize for getting this up. This is on Sunday afternoon around 5. Hopefully you guys enjoyed your extra hour of rest that you got last night. And anybody feel the shaking from the earthquake in Oklahoma? That was a little trippy. Anyway, I'm sorry. I'll get to work here. We're gonna combine our sum and difference properties with some things that we've learned before, doing general solutions. I know that's a dirty word for some of you. And so tomorrow what you're going to do is you're going to have to play the matchy-matchy game with your formula chart, and then we're going to actually solve the equations. So let's get started here. I've got two examples to do. We're going to find the general solution, and then we're going to find particular values on the interval from 0 to 2 pi. So this first example here, I've got cosine x cosine pi over 4 minus sine x sine pi over 4 equals 1/2. And that looks like a pretty intimidating equation. Luckily for us though, this left-hand side can be written as the cosine of a plus b, because this matches the cosine a plus b formula. So the a is the first angle and the b is the second angle. So this can be condensed into the cosine of x plus pi over 4. That entire left-hand side looks just like our cosine of a plus b formula. So I condensed it into cosine of x plus pi over 4 equals 1/2. And then the next thing that I'm going to do is take the arc cosine of both sides. So x plus the pi over 4 is equal to arc cosine of 1/2. So let's see if we can't remember what that is. Arc cosine of 1/2 without a calculator. This better be one of our special angles, 30, 60, 90 or 45, 45, 90. Let's go see. We can put arc cosine in quadrant 1 because it's positive. Arc cosine is adjacent over hypotenuse, and the Pythagorean theorem, square root of 3. Looky there. It's our 30, 60, 90 ratio. And so we're going to need to find here is, what is this angle right here? Well, that angle is the 60-degree angle because it's across from the square root of 3. So I'm going to call that pi over 3. So I have x plus pi over 4 equals pi over 3, and then of course plus 2 pi n as soon as you do arc cosine or arc sine or arc tangent. And then the other equation is x plus pi over 4 equals, since we're dealing with arc cosine, the other reference principal inverse value is the negative of what we found before. So I have negative pi over 3 plus 2 pi n. Then all I have to do is subtract pi over 4 from both sides. So I'm going to think about that as over 12s. So pi over 4 is really going to be 3 pi over 12. And then pi over 3 is going to be 4 pi over 12. So when I subtract pi over 4 from both sides here, let's see what that's going to get us. So pi over 3 was 4 pi over 12 minus 3 pi over 12. Well, that's just 1 pi over 12, right? Plus 2 pi n. And then when we do the same thing on this side, minus pi over 4 minus pi over 4, I'm going to get negative 7 pi over 12 plus 2 pi n. Okay, there are the general solutions, and that's how I can find, the first three positive, all things that we've done before. But my part B does not ask me to find the first three positives. It just says find the particular values for 0 to 2 pi. This means we have to find every angle bigger than 0 but less than 360. Well, the first one is right here, pi over 12. And the second one can come from this second equation. However, the second equation has a negative angle in it, so I'm going to have to add 2 pi to that so I can get to the next angle. And negative 7 pi over 12 plus 2 pi in the nice little 24 over 12 version of it, there's your 2 pi. If you add that up, and you get 17 pi over 12. Now notice that if we went back to this one to get the third one, if I added 2 pi to that, I'd get 25 pi over 12, which is just outside our range. So that is my answer for B. Okay, so let's go down here to our next page and do our next example. Example 2 has a tangent equation that looks pretty messy, equals negative square root of 3 over 3. But if we look at our formula chart and we play the matchy-matchy game, this is the tangent of a minus b formula. And that is our a, and that is our b. So I'm going to have the tangent of 2x minus x equals negative square root of 3 over 3. We're going to arctan, well, let's simplify this right here. That's just x equals negative square root of 3 over 3. Now let's arctan both sides. Okay, negative square root of 3 over 3. And let's see if we can't draw that. Arctangent, we're going to draw that in We're going to draw that in quadrant 4. Alright, let's see. Opposite over adjacent. And this is a really weird version. Of course, you know, some of us have seen this before. If the person that wrote this question had not rationalized their fraction, it would have looked like this, and it would have been much easier to see the relationship that's a 30, 60, 90. But as it is, I actually have to do the Pythagorean theorem, and I end up with 2 square roots of 3, and this is a really weird version of the 30, 60, 90 triangle. If they hadn't rationalized that and had left it in this form, negative 1 over square root of 3, I could have drawn this picture, opposite over adjacent, and it's much easier to see the 30, 60, 90's relationship. Oh well, but this reference angle right here is across from the smallest side. That's a 30-degree angle, so that's pi over 6, and it's in quadrant 4, so that answer is negative pi over 6, and then plus pi in. Plus pi in only because it's tangent, and we don't need a second equation, so there's my answer for A. And then for B, we just want all of the solutions from 0 to 2 pi. So negative pi over 6 is not 0 to 2 pi, so we're going to add pi in. Of course, I'm going to add pi in the version 6 pi over 6. So if you add 6 pi over 6, you're going to get 5 pi over 6. And we're still not to 2 pi, so let's add pi again. We get 11 pi over 6. We are almost to 2 pi because 12 pi over 6 is 2 pi. And if you added 6 pi over 6 again, you get to 17 pi over 6, which is outside the range. So we just have to play a matchy-matchy game with our formula chart, and then we have to solve equations. So I will see you guys tomorrow.